Hi everyone and welcome to this video. So today we have a lot of interesting topics to cover, so let's start right away. First of all, we are going to see a little bit what a computer is, then we will introduce what a computer program is, and then what a programming language is. Afterwards, we will be able to introduce basics for the first time. So when discussing the basic language, the very first thing that we are going to discuss is the integrated development environment, or IDE, that you see on the screen here, which is QB64. This is what I suggested to install in the last video. So if you haven't done it yet, I suggest you to go to this website here and download and install a QB64 properly. So once you have the QB64 IDE, I will explain a little bit how to operate with it at a very basic level, of course. And then we will be able to start to discuss a little bit about the basic language. So the very first thing that we are going to introduce is what is a variable, and after that we will be able to discuss a little bit about what mathematical operators we expect to find in the basic language. Right after that we will be able to introduce a few commands, the commands that are very easy to understand. The commands are print, CLS, and input, and rem. So these commands are pretty easy to understand, but what I promise is that in this video I will show at least a few examples for every command so that it becomes very simple to understand how to use them in practical cases. All of this is twofold. If you are already an expert in BASIC, think of this as a memory refresher. And if you are just starting in BASIC, then you can really see this as a step forward to understand BASIC. There is also a book that I suggest every time, and this is the book that you see on the screen here, which is not a new book, so they don't print it anymore. And this is a book from 1993. But it's very simple and easy to find second-hand copies on the web, so that's why I suggested it. So the book is called QBasic by Example. This is a book from Greg Perry, and this is QUE Publishing. As always, I want to thank all of you for being here today. I never expected that I would create this sort of videos, so having you guys around here, sharing those videos, subscribing, and everything that you are doing to encourage me, this is very much appreciated. Thank you so much. So let's start with the first question, which is what is a computer? So you can think of a computer as an electronic device, of course, and you can think of this device as made of several parts. But one part is more important than any other part, which is the central processing unit, or in short, CPU. What is a CPU? You can think of the CPU as a chip that performs instructions. The chip is connected to your motherboard on the computer, and this is what runs every single program that you are running on your computer, no matter if it is a video game, or if it is a web browser, or if it is the operating system itself. Everything goes through the CPU. The CPU therefore is a chip that can perform commands, but how can it understand those commands? The CPU has a language which is called the machine language, and you can essentially provide a list of commands that are written in this machine language. So that brings us to the second question, which is what is a computer program? So a computer program, essentially in this view that I just introduced, is just a list of commands. But the list of commands is ordered, and those commands are written in such a way that you can obtain something practical that you would like to obtain. For example, the list of commands could be something that make the computer perform a video game. So then this brings us to the next question. If a CPU can understand only machine language, how can we provide the commands that we would like the CPU to perform? Well, machine language is one of the possible language that one can use. Machine language is very difficult to understand for humans, so you can imagine that people during the years have created programming language that are way easier to understand than machine language. So when I talk of a programming language here, you have to think of a language that is very close to English, something that human beings can understand, but then this language is going to be translated by some tool on the computer into machine language so that the CPU can understand what you would like to achieve with the computer. One of these programming language is of course BASIC, and this is why now we are going to talk about BASIC. Before we go straight into the basic language, there are a few things that I need to explain though. And the very first thing that I'm going to explain is this QB64 IDE, or Integrated Development Environment, which is essentially what you see on the screen here right now. First of all, if you use your mouse or the Alt key on the keyboard, you can access this menu here. I think you should be familiar with these menus. If you are not, I would strongly suggest to get familiar with them by essentially experimenting with them. But essentially you are going to understand what they mean. For example, new means that if you want to start from scratch and write a basic program, this is what you should use. If you want to open a program that was previously saved, that's what you are going to use. If you want to save your program in two different ways, you can use the save or the save as options. The same goes with the edit menu. You have undo, redo, which I expect you should be familiar with, even coming from other languages or coming from other programs. And the cut, copy, paste, clear, select, all these things, I mean, you should be familiar with them. If you are not, I suggest you to play a little bit with these. You will see they are very easy to understand. And of course there are plenty of other menus, but the most important one is the run menu. Essentially every time we are going to write a basic program, we are going to go into this menu and practically choose the start option that is going to translate our basic program into machine language that the CPU can understand. This might sound a little bit overwhelming for the beginners, but don't be overwhelmed. I'm going to explain this in practical examples so you will be able to follow. Before we start to explain variables though, we are going to use the IDE and to create a new program. So I'm going to use the Alt key here, go into File, and I'm going to click on New. You can do this through the keyboard or you can do this by using the mouse, it really doesn't matter. But once you click on New, you have now a window here that is opening and telling you that the program is not saved. So do you want to save it? Since we want to start from scratch, we are going to say no. And I've used the Tab key to go to and click to no, but of course you can use the mouse for this. So now let's discuss a little bit what a variable is. You can think of a variable in BASIC as a very simple concept. It is a box in a way. I mean, you can use this analogy, and the box has a name and the box has something inside of it. So what is inside of it could be something that a computer can understand. For example, a list of characters, or it could be a list of numbers, or it could be even just one number. And why do we need variables? Because we don't want to refer to this list of numbers of characters every time. We would rather prefer to refer to that list through the name of the variable. So variables becomes a very convenient way to convey information inside a basic program. Let me do an example. Let's say that we are developing a video game and we would like to fix once for all what is going to be the number of colors that we need. So one thing that we could say is we could call a variable num colors, and we could assign a value to this variable that is going to be 32. So now what it means is that we don't need to remember what is the number of colors every time that we are writing something into this new program. We can refer to the name of the variable which contains the actual number of colors. Another example of variable could be a list of characters. In this case, in BASIC, you cannot just give a name to the variable, but to make the program understand that you are now dealing with a list of characters, you give the name of the variable, let's say in our case list01, but then you have to add the $sign, and if you add the $sign, then BASIC understands that this is a list of characters. And the way you represent the list of characters is that you are going to use the double quotes, and everything that is inside double quotes is essentially a list of characters. So even if I add here, for example, these two numbers here, 9 and 9, BASIC is not going to consider them as numbers, but is going to consider them as characters. What can we do with variables then? I'm going to present a few examples, but I will mainly focus on variables that contain numbers for now, so that everything is still kept very simple. So let me remove this other variable here, and let's introduce other variables. So let's say that we have a variable a that is equal to 5, and let's say we have a variable b that is equal to 15. Now we would like to have a variable which contains the product of these two variables. So we could practically do this. We could call a variable c and say that c is equal 5 times 15, which is written like this in BASIC. But this is definitely not a very convenient way, because if your variable a or your variable b change values in time, and you will see that this is possible in BASIC, then you have to redefine by hand the variable c. So a better way to handle this is to actually say that c is equal to a times b, which now means that in practice every time the variable a or the variable b changes, essentially the variable c is going to change as well. Of course, I'm oversimplifying everything, but this is just to make you understand at the moment. So if we would like, for example, divide b by a, we could define another variable and call it d, for example, and d would be b divided by a. In BASIC, this is the way we write it. We use the slash to introduce the division, while here I've been using the asterisk to essentially introduce the multiplication. In the same way, we could define other variables to define other operations. For example, we could define a variable j that is equal to a times b minus b divided by a, plus a, for example. And all these expressions that I'm writing here, these are mathematical expressions that are valid in BASIC. What BASIC is going to do is it's going to use the values that are defined here for a and b, and then it's going to compute the value of c and d and the variable j. So of course we cannot really see any of these if we don't run the program. So one thing that I'm going to do is I'm going to introduce a new command which is called print. Print doesn't print anything if you don't have a printer. Print is going to show something on the screen. The command is called print because very old computers, when they started to implement BASIC, essentially they would actually print things on a piece of paper. So if you want to see what is the value of the variable a, you just have to say print a. If you want to see what is the value of the variable b, you say print b. And if you want to see, which is even more interesting, the value of the variables c and d, you have to go and do the same thing. It would also be interesting to see the value of the variable j. So now if we go in the menu and we click on run, and then we click on start, or we hit the F5 button, something very interesting is going to happen. First of all, the basic IDE that we have here is going to translate the basic program into machine language, which is also called a compilation. So essentially the IDE is going to compile your program, and it's going to make it in a shape that the CPU can understand. So if we now click on start, this is what you see. First of all, it is creating the exe file, which is essentially a file that will be understandable by the CPU. And then we have this new windows that appears, and we have the value for the variable A, the value for the variable B, and so on and so on and so on. And if you double check these results, you will see that these results are correct. So in a way, you can use BASIC as a sort of calculator. So having the 4 operations in BASIC is interesting and certainly useful, but that's not the only thing you can do. For example, you have, and I'm just going to introduce 2 different examples here. You have an operation for modulation. So say you want to know what is the remainder of B divided by A. You could do in the following way. You could write B mod A, and this is going to show you, this is going to divide B divided by A, and it's going to tell you what is the remainder. In this particular case, is going to be 0. But also you have more sophisticated things. For example, say you want to know what is the value of B exponent A. That's the way you do this in BASIC. Now that we have seen how to perform a few operations, how to define values for variables, and how to print them on the screen, more or less, it would be interesting to go on a more sophisticated example, still a very simple and concrete example, so that we can see a few more things about the commands that we want to use. So the very first thing we are going to do, we are going to click New on the IDE, excuse me, and we are going to try to do something different this time. And what we would like to do is the following. Let's suppose that we know the quantity of something we are buying, we know the price, unitary price, and we would like to know what is going to be the total price that we want to pay. Also, we would like to see this on the screen in a very nice format. So let's see how we can make a code that does that. So the first thing we are going to do is we introduce a variable, we define a variable where we define the quantities of something that we are buying. Let's say that we are buying 16 units of this product, whatever it is. And let's suppose that we know the price, and the price, when I mean price, I mean unitary price. And let's suppose that the price is $2.50 per unit. So the total price that we are going to have to pay is the quantity times the unitary price. Now what we would like to do also is to print all of this in a very nice format. So the very first thing that we could do is the following. We could use 3 different print commands and print the quantity, the price, and then the total. Let's try to do this and let's see what happens. So let's go here on the Run menu and click on Start. So this is compiling now our basic program and transforming it in a machine language program that the CPU can understand. And what you see is that we have 3 numbers in this new window that just pop up. And it's 16, which is the quantity, 2.5, which would be 250, which is the unitary price we introduced, and then we have 40, which is the total price we should pay for 16 units of this product. So all of this works, it provides the right number, but at the same time, I mean, the format is not very, very nice. So let's see if we can do something different. So the very first thing we could do is this. We can add a few characters so that we understand what we are showing on the screen. And what we could do is the following. We could say, okay, before QTI, print quantity equal with the space here and the space here, and then we have this semicolon here that is going to practically attach the value of the variable QTI to this series or to this list of characters that we have. In the same way, we can do the same here for the price and the total price. So we could write here price equal, and actually if we want to be even more specific, we could say unit price, and then here we could say, okay, this is the total. The total is going to be equal to this. And maybe if we want to make things a little bit fancier, we could add a few spaces here so that practically all the equal signs here are aligned. So let's try to run this and see what happens. So we go in the menu again, we go in the run menu and we click on start. What we see this time is that we not only have the numbers, but we also have this list of characters that usually in BASIC is called a string, and from now on we'll call it a string. So what we have done is that we have a string every time and then the value of some variable, and this is what we are printing. But we could do even slightly better than this. Let's say that I want to have the unit price and the quantity on the same line. In this case, we could remove the print here, go here, add another semicolon, and then we can add the space here. If we do this, what you are going to see is slightly different. Let's try to compile. So if I'm going to run and click start again, this compiles as usual. And now we see something that is slightly in a better format. So what we have learned here is not only that we can write programs that looks slightly better, but we have learned something very specific, which is if we use the command print and we add a semicolon here, essentially whatever we put between semicolons, or let's say in a better way, if we put a semicolon between two things, these two things will be printed on the screen, they will be shown on the screen, but very close to each other. So this is a way to actually control the format of something with the print command. Now that we have written this program, can we do something better about the format of the program itself? Let's say that I bought a product here and that I have computed the value or the total of what I need to pay, but I don't want to forget when the purchase was done and what was the product. So in this case, what I can do is to add the command rem, that is short for remark. And everything that I'm going to write after a rem command will stay in the code or in the program, and nothing will happen. So anything that you write after rem, it's actually just a remark for yourself. So let's say in this particular case, rem could be, okay, product is, I don't know, let's say a pack of chips, and let's say that we bought them today, which is the 2nd of December 2024. So now I have these remarks here, and if I try to run the code, which is what I'm going to do right away, you will see that there is no difference in the output of the program. These are essentially just remarks. They are not even compiled by the IDE itself, so they are completely ignored, and this is just a command for yourself or for whoever is going to read this program eventually. Another thing that you have to notice though is this: if I write rem and then I write an actual basic command, what's going to happen? Let's try to do this. Let's say that we want to write something like this, it doesn't really matter, and we have a rem right in front of it. So if we try to compile now, so we try to run it, what you will see is that the output is still the same. Why it is like that? Because again, anything that goes after a ram command is completely ignored by the IDE. On the opposite side, if I now remove ram and I try to run this program, you will see that now the first print is actually performed. You can see this is the very first line that we see in the new window. And finally, this is also a very nice trick in case you have a command in your basic code or in your basic program and you would like for a test or something, you would like to remove it, but you want to still keep the command in the program. So then what you can do is the following. You put a ram and then the command is completely ignored. Another way to introduce a remark in your basic program is the following. If you use the single quote here, this is going to be exactly the same. So let's try to run this code, and if this is the case, we shouldn't see any weird print at the beginning of this window. Now another thing that we can do with this example is the following thing. So let's suppose we remove this remark here and we have this print, but for some reason we want to show it at the very beginning of the program and then we want to get rid of it so that we can see these other prints but in a very clean way. So one thing that we can do is to use the command CLS, which stands for clean screen. And if we run this code now, you are going to find something new here. So let's run it. And what you see is the following. We didn't even have the time to see the string L, K, J, D, S, and so on, because the command CLS removed it and we didn't even have the time to see it. It was too fast. But then you clearly see that the command CLS performed what it was supposed to do, because what you see now is that the screen has been clean and then the last output that we have in the program has been performed. So this CLS command is very important because it allows you to see things on the screen, then to clean the screen again, and then to print different things on the same screen. Also, another command that is very interesting and very useful is the command AND. So let's suppose that we are running this program here that is very simple, but for some reason we want to stop the program after printing what is on line 4 here that you see. So one way to do this is to use the command AND. Whenever the program will reach the command AND, the program will stop. So in this particular program that we wrote here, this is what is going to happen. The RAM here are going to be completely ignored, then the print here is going to be performed, and then the instruction AND here is going to terminate the program. So whatever you find here in the rest of the program is never going to be performed. Let's see if this is the case. So let's try to compile and run this program. And if everything goes well, exactly, we should find this string L, K, J, D, S, L, and so on, but nothing else that is written in the program has been performed. So this is because the program actually stopped here. This is, you might ask for now how and why such a command would be useful. You will see with time that this can be actually very useful. There might be situations where we are running something that takes a long time and then eventually we want to stop it. So one way to stop the program in a very clean way is to use the AND command. Another thing that we are going to do though, which is very good practice in BASIC, is that we are going to add the AND command at the end of the program. Another thing that we are going to do is we are going to remove this print command here because we don't actually have a use for it. And now this is the new program that we have. So if we run it, what's going to happen, it's going to clear the screen, define the value of these two variables, then compute the new value of this variable here, and then print the value of everything. And we are now at the end of this video. This is the final part where we are going to try to do something slightly more sophisticated. So far what we have done is to define the value of these two variables, QTY and price. And this is good, it works for us because it allows us to perform a few operations on these two variables. But what if you don't know the value of these two variables and you want to introduce this value whenever you need to introduce them? Let's say that you want to ask the user to introduce the value. How can you do this? There is a command for this in BASIC, which is the input command, and I'm going to show you exactly how this thing works. So rather than now assigning a value, what we are going to do is this. We keep the value of price to 2.5 or let's say $2.50 per unit, and then we are going to ask the user to insert the quantity. And by doing this, I mean, how can you achieve this? By essentially using this command here, which is called input. So what is going to happen is that when we run this program, the program is going to ask what is the actual value of the variable quantity or this variable QTY. And after that, it will provide the solution to our problem, which is what is the total price. So let's try to run this and see how it works, because if we see it in concrete, it becomes very quickly easy to understand what we mean here. So if I run it, this is what happens. I have now a question mark in the window, and the question mark stands for what is the value of QTY, the variable QTY. So I'm going to insert 16 and hit the enter key excuse me, and then this is what you see. It did work exactly like it was working before, just that rather than inserting a fixed value for the QTY variable, this value was asked to the user in real time during the run of the program. So what would happen, for example, if we would be a little bit clearer? I mean, a question mark is nice, but it's not really, it's not very clear. So one thing that we could do here that looks more or less like what we did with the print command is that we can actually add here a string that is going to clarify for the user what we are asking for. So if we now try to run this new program here, you are going to see what happens. And now, as you can see, the prompt is way clearer. I mean, rather than having a question mark, now we have QTY equal. And the user knows immediately what we mean here. So if we write 16, this is what we get. We can try with different values. So let's try to do this. And rather than 16, let's say 8. And this is what we get. So it still continues to work. It's just that now we don't fix a value for the variable QTY. We ask the user to introduce it. So can we do the same for the price? Well, the answer is yes, and it's pretty easy at this point to understand how to do this. We are just going to write the command right away here, and what we are going to run this program. So what the program is going to do is it's going to ignore these first two ramps, it's going to clean the screen, and then it's going to ask the user what is the unit price, then it's going to ask the user what is the total quantity, then the program is going to perform this multiplication and show on the screen what is the total amount to pay. So let's try to compile the usual way. And let's see what happens. So let's provide a value of 2.50 like we did before, and let's say that it's 16 in quantities, so we get the same values. If we try to run this program again with different values, this is what we are going to get. Let's say now we are buying something for 50 cents unitary price, and we are buying 4 of them. And what the program is saying is that the total price is going to be $2. And as you can see, everything works, everything is fine, and everything seems to be way clearer than before. So we are going to stop here for today. For the beginners, I warmly suggest you to try all the examples, to go through this video, to stop it at any moment. If you have any comment, if you have any questions, I would be more than happy to take them in the comments below. I thank you very much for your attention and see you next time with another video.